So that's an often asked question is what is the difference between ozone and the hydroxyl? Hydroxyl being less known. So basically the hydroxyl molecule is lighter, slightly lighter than air. Ozone is heavier. Ozone is challenged whenever there's moisture because it just doesn't have the kinetic energy to punch through a moisture barrier. So anything that's above 8%, it really is challenged. So you really have to dehumidify the air in order for it to work. Whereas hydroxyls are excellingly good at working in a moist environment, and that's usually where you have flood and fire type of environments where it's high moisture. So the higher the moisture content, that's simply more fuel for the hydroxyl reaction. So it is not burdened by that. It can get through the water vapor to attack bacteria, virus, odors, and fungal matter. Well, ozone has how would you say, the distinction of not being good for the human body in that on the exterior, when you inhale it, anything that is above 0.02 tends to be an irritant to the lungs, and this is a NASA figure, and the slides are available to view. And of course, the OSHA limits, or the workplace limits here in the United States, are at 0.1 parts per million, or slightly less than that. So if it's at that or slightly higher, you will have irritation to the eyes, to the throat, and so on. It's just not a pleasant work environment, so we would like to see it, as the government mandates, at that level or below. And so when it comes to the world of chemistry, which really took off after World War II, since 1945, chemistry has been the way to go. The catchphrase was a better world through chemistry. And so we've come up with a plethora of chemicals to address surfaces, sprays into the air to address microorganisms and so on. And they've been used regularly in hospitals and care facilities and in homes since that time. The mechanism and how it works is that you have to spray that area. In order to get a 2-log reduction, which is 99%, that area must remain saturated for at least 10 minutes. And so you can imagine that it becomes pungent after a period of time, and it's very difficult to address your flooring, your walls, and your ceiling. That's a lot of chemical. And so the difference between chemistry and using hydroxyl, which is a natural mechanism in the atmosphere, is that you can run our equipment 24 hours a day. We don't have to wait till the room's vacant. It addresses surfaces, hard, such as stainless steel or wood or your tiles, but also soft surfaces like our clothing, our bedding, our carpets, and our draperies. So it is able to be deployed 24 hours a day, whereas chemistry cannot be. You can breathe hydroxyls because they occur naturally and at the same amounts that nature produces them. We produce them indoors. Whereas chemistry, you basically have to wait till the room's unoccupied. So for the first time, we're ahead of that battle. When addressing surfaces, we've got a host of chemicals that can do that in the marketplace and have been there for many, many years. But when you address just the surface area, the air volume is not being addressed. And the figures are from Penn State University that 82% of all illnesses come through our eyes and through our nose. So that has to be in the air stream. So if we're looking after the surfaces, what's taking care of that large volume? Now that was meant to be done out of doors. Hydroxyls exist there. They perform that service tirelessly 24 hours a day. And when we seal off our buildings, we just don't allow that natural structure to enter into a building. And so it's very important that we reestablish that balance. And when we do, it tends to dry up those issues of bacteria, virus, and fungi in the air, as well as your chemicals that are airborne.